Alright, use the definition of continuity on page 229 to determine whether or not the piecewise function is continuous at x equals 2. Support your answer by sketching a graph. Alright, well, for something to be continuous, we need three things. We need f of, so we're doing 2. So we need f of 2 to be defined. We need the limit as x approaches 2 of f of x to exist. And finally, we need f of 2 to equal the limit as x approaches 2 of f of x. That's what your book says. The way I like to think about it is we need the limit as x approaches 2 from the left of f of x to equal the limit as x approaches 2 from the right of f of x. Notice that essentially means that the limit as x approaches 2 exists, and we need that to equal the value of the function at that point, f of 2. That's how I like to think of it. That's how I will show it. So we want to find the limit as x approaches 2 from the left of f of x. Well, if we're approaching from the left, we are less than 2. So we're this function. So we can directly substitute into that function negative 2 times 2 squared plus 6 will give me, what does it give me? Negative 2, I believe, right? 2 squared is 4. Negative 2 times 4 is negative 8. Negative 8 plus 6 is negative 2. All right. Limit as x approaches 2 from the right of f of x. Well, if we're to the right of f of x, then we are bigger than 2. If we're to the right of 2, I should say. So directly substitute into that bottom part of the function there. So 3 times 2 minus 8, and again we get negative 2. And notice that is for x greater than or equal to 2, which means that f of 2 also equals 3 times 2 minus 8. So the limit from the left equals the limit from the right equals the value of the function there. Therefore, this is continuous. So let's sketch a graph. So some axes. Let's go 1, 2, 3, 4, 5, 6. I'm going to graph this parabola. Let's go 1, 2, 3, 4, 1, 2. Alright, if I'm graphing this parabola, negative 2x squared plus 6, I see that it's shifted up 6. It's got a stretch factor of negative 2, so if I go over 1, I should be going down 2. Over 1, down 2. If I go over a second point, I'd normally be 4 away from that vertex vertically. Well, now I'm 4 times negative 2 away, so I'm down 8. So boom, boom, that point's going to be there. And then this point would be open right there on that parabola. So it's going to look something like that. And then the linear function 3x minus 8, well, we already know that at x equals 2, it's starting at that value of negative 2. So it's going to start right here. So it's going to fill in that gap, and it has a slope of 3. So one point over is going to get me there. Another point over is going to get me up here. And so that's that. And then there's that parabola. It is continuous because those points meet, and we've satisfied the definition.